Nullius in verba is a Latin phrase that means on no one's word. This is the phrase that was chosen as the motto for the fellows of the oldest scientific organization, the Royal Society of London. Why did they choose this Latin phrase? The answer to this question is also the answer to what is science? Science is often thought of as a collection of answers to questions like, how long does it take light from the sun to reach the Earth? Answer, 499 seconds. Or, why is Mercury liquid at room temperature? Answer, Mercury's valence electrons are closer to the nucleus, which results in relatively low amounts of heat being required to break the weak binding between atoms of Mercury. Or, why is a raven like a writing desk? Or, at room temperature, why does metal feel colder than wood? Answer, the metal transfers heat from your hand more easily than wood. This property is called thermal conductivity. Are those questions different than who was President of the United States in 1907? If so, how are they different? The difference between those questions is that the first three were answered through the process of science instead of written history. Science, however, is not a collection of facts. It is a process that aims to find objective truth rather than subjective truth, or in other words, nullius in verba. So let's imagine you're sitting in an English garden waiting for the sun, and you see an apple fall to the ground. How would you describe this? And more importantly, what is the process that would remove the subjective from the objective? The process is called the scientific method. The first step in the scientific method is to define the question. In this case, the question would be, what happens when an apple detaches from a tree? The second step is to observe. Again, in this case, when the apple detaches, it falls to the ground. The third step is to form a falsifiable hypothesis. This is a key step in the scientific method. If you form a hypothesis that cannot be tested, from a scientific perspective, that hypothesis is not useful. You must form a statement that can be tested, or in other words, a statement that can be proven wrong. In this example, the hypothesis is everything that goes up will come down. The fourth step is to test the hypothesis. So, get some items and let them go from a variety of places, i.e., drop a bunch of things in a bunch of locations. The fifth step is to analyze the results. Everything that was let go fell to the ground. The sixth step would be to share the results, so show your findings to other people. Finally, the seventh step is the retesting of the hypothesis by others. So, have other people drop things and have them analyze the results. The last step is very important, because having someone observe the same thing, independent from other measurements of the same phenomenon, is a strong piece of evidence that supports the original findings. Gravity is probably something you have observed and internalized a long time ago. After all, it is a force that is omnipresent in life. This was the view of how gravity worked until Isaac Newton had a revolutionary thought. Others had started applying math to the force of gravity and started to approximate Earth's gravitational force. Newton realized that gravity is not only responsible for things falling to the ground, but gravity is responsible for planets revolving around the sun and for the moon revolving around Earth. The marriage of these two ideas was truly revolutionary. But there's a question that you have probably already asked. Why doesn't everything just collide into each other? Well, imagine putting a cannon on a very big hill and firing it. The cannonball will probably go a certain distance and will fall back to Earth. But what happens if you fire the cannon really fast? While the ball is being pulled toward Earth, it is also going far enough for the curvature of Earth to be a factor, and while it's falling, it is also outracing the curvature, so it never falls back to Earth. This is how the planets revolve around the sun. So, what goes up does not necessarily come down. Many people thought that humans could not actually launch something so fast, but on October 4th, 1957, the Soviet Union launched Sputnik, the first man-made object to revolve around the Earth, and started the space race. By then, the view of gravity had evolved, but Newton was close enough for the majority of day-to-day gravitational events. The scientific method can also be used to prove things. For example, the myth that sugar causes kids to be hyper. How could you determine if sugar causes kids to be hyper? Easy. Just give kids some sugar and see what happens. Result? Kids became hyper. But maybe the kids hadn't eaten in a while and that's why they were hyper. Or maybe they were excited for the candy. Let's rerun the experiment. Separate the kids into two groups. One group gets candy, the other doesn't. And as long as you control for things like when the kids have last eaten, you can make a determination. This is called a controlled trial. You might still get the same results of the kids being more hyper after candy, but there's a problem with the setup of this experiment too. Maybe the kids who didn't get candy were grumpy about that, and maybe the other kids were excited to get candy. So, rerun the experiment, give one group candy, and the other group sugar-free candy. As long as the kids do not know the difference, you'll be fine. The sugar-free candy is called a placebo, and this type of trial is called a placebo-controlled trial. While this might seem like enough, there may be differences between the two groups which causes your conclusion to be false. Maybe one group had more girls, and that's where the difference comes from. To rid yourself of this kind of bias, you must randomize the process of how you assign kids to each group and make sure the people who are interacting with the children do not give subtle hints to which group each kid is in. You must make sure those who have interaction with the children do not know which group each child is in. This is called a double-blind, randomized placebo-controlled trial. This type of trial is very hard to do and even impossible for some things. But it is how we prove causation and not just correlation. This kind of study has been conducted 12 times on sugar and hyperactivity in kids. And the result is that there is no difference in hyperactivity between a kid who is given sugar and a kid who is not given sugar. So, where does this myth come from? Researchers have conducted the last trial, but instead of giving one group candy with sugar, give each kid sugar-free candy. But tell one group's parents that they received the candy with sugar and have them rate their kids' hyperactivity afterward. The result? Parents who were told their kids had sugar rated their kids as more hyper after they ate the candy. We all have biases, and many of us have biases so strong, so set, that we believe something like sugar causes kids to be hyper. So, next time you read something online or hear something that reinforces something you believe, before you share it, before you internalize it, think to yourself, am I choosing to believe this because it is true, or am I believing this because it is easy?